I wrote it.
So, stoichiometry is the relationships between substances in a balanced chemical equation. Reactant to reactant, product to product, or reactant to product, any of these you can determine from a balanced chemical equation. Why do we balance chemical equations? Go on? Yes. Yeah, we don't create or destroy matter, so you have to balance your chemical equations. All right. So, write a relationship between hydrogen and oxygen. Write a relationship between, write it down, commit to it. Write a relationship to hydrogen and oxygen. Commit to it. Write it down on paper. Don't wait to be given an answer. Commit to something. Alex, what did you write?
So 2H2 combined with 1O2 make 2H2O.
You said two H2s combine with one O2 to make two H2Os.
Yeah.
That's what you wrote. 2H2 what?
Molecules.
2H2 molecules react with or combine with one molecule of oxygen. So we can say that. We can say two molecules of H2 combine with one molecule of O2. We can say that. And we would make only two molecules of water. The fact that you can isolate only two molecules of H2 would be quite tricky. This can also be put in terms of moles. You have moles of molecules. So we could also take this statement and say 2 moles of H2 molecules combined with 1 mole of O2 molecules. But chemists need to be efficient. We need to be able to convey this information in a clearer, more concise manner. So we use what we call mole ratios. And you've already used ratios when you look at Avogadro's number and using dimensional analysis. You set it up as a ratio. Same thing here. 2 moles of H2 combined with 1 mole of O2. Yeah, so this will be the exact same thing if I put 1 mole of O2 on top and 2 moles of H2 on the bottom. The relationship is the same. 1 mole of oxygen will combine with 2 moles of hydrogen. These are called mole ratios. And they are very important, and you need to know how to write them. So now, write me out, commit to it on paper, a different mole ratio for a relationship in that chemical equation. It has to be different than that. But it has to involve that chemical reaction. So give me another relationship. You asking a question?
Yes.
Okay.
Hey, let's say you want to do like the reactant with a product, right? H2, right? Would you still put it like
2 and 2? Yeah.
okay.
Appreciate it. Rhea, what'd you write? 1 mole of H2O? It would have to be 2. Where are we getting these 2 and 1s from? 3. Yeah, the numbers in front in the chemical equation. What do we call those numbers in front? They have their own name. Coefficients. The values that you use here are the coefficients from your balanced chemical equation. Don't reduce them. I mean, you know that they reduce when you're doing math with them, but don't change them in your mole ratio. Have them be what they are in your chemical equation. Did anybody have something other than this? Oxygen to water. Caitlin, what did you have?
I had 4 moles of hydrogen over 2 moles of oxygen.
4 moles?
Or just hydrogen without H2.
But the number in front is, okay. Artistic license. You can't change the numbers. Okay, you can't change the coefficients. You have to use them. So if we've used hydrogen to oxygen, that's reactant to reactant. We've got oxygen to water. There's only one other ratio we can pick.
2 moles of hydrogen, or 2 moles of...
So we can have 2 moles of H2 to 2 moles of H2O, or any of these you can flip them over. The relationship doesn't change. You're going to use them as you need them.
Can we do 2 moles of H2O per 2 mole H2 plus 1 mole O2?
No,
No.
don't add. Just have it between 2 substances. Luke, the same question? Yeah, don't only have it 1 to 1. 1 reactant, 1 reactant or 1 product. You're welcome.
Will we do that eventually? Or
No. When you go to university, you're going to see a lot of questions. Here's information about substance A, but I want to know about substance B. So it's always between two substances. And you'll be able to do that this year. In fact, next week. Okay.
3BR2 is equal to 2AR, BR3.
Beautiful. All right. So if I produce 5 moles of aluminum bromide, how much bromine would I need? So the question is, how much bromine would I need to use if I want to make 5 moles of aluminum bromide? So what you do is you write down the information. You either start with what you know or you start with your mole ratio. We want to find bromine. So what is the mole ratio? What is the relationship between bromine and aluminum bromide? Yovam?
3 moles of bromine, or BR2, over 2 moles of aluminum bromide.
Beautiful. Now, if we multiply it by the amount of aluminum bromide that we have, moles of aluminum bromide go. So now the units in your answer are moles of bromine. So 3 times 5 divided by 2, like 2. 7.5. So we need to have 7.5 moles of bromine. This is a crucial tool for a chemist. Whether you end up in a lab or whether you end up being a chemical engineer, you're going to need to know the relationship between your reactants and your products. How much aluminum would you need? 5 moles. It's a 2-to-2 ratio, so 1-to-1 ratio, right? 2 of these to 2 of these, so that's a 1-to-1 ratio. If you reduce it, so you'd need 5 moles. And you would do it the same way. Start with your mole ratio. Multiply it by the moles of aluminum bromide that you have. So whether or not you want to use formulas or dimensional analysis, this concept will be used by both. You can't get away from mole ratios. Okay, let's do another question. This is a very popular reaction. You'll see it a lot in grade 12. And this is one way that we produce a lot of ammonia, which then gets used in a lot of different products. So this is one of the biggest produced chemicals. So, balance it. If we have 2 moles of hydrogen, how much ammonia can we produce? How much ammonia can we produce if we have 2 moles of hydrogen? Show your work. So you're gonna start with your mole ratio. That's ammonia. So what number do you get?
1.3.
So So 1.3 moles of ammonia maximum can be produced if you use up your 2 moles of hydrogen gas. It's assuming everything goes smoothly and that nitrogen is limiting. How much nitrogen would you have to use?
Pardon?
How much nitrogen would you need to use? No, because it's not a mass. Yeah, you got to use your mole ratios. So set up your mole ratio. We want nitrogen now. Oh, sorry, yeah.